Throughout the history of space exploration, mankind has achieved remarkable feats and pushed the boundaries of what is possible. However, alongside the triumphs, there have been numerous failed missions that serve as reminders of the inherent risks and challenges of venturing into the vast expanse of space. Let's look into some of the failed space missions and how they changed our view of space. The Mars Climate Orbiter. The Mars Climate Orbiter mission was a collaborative effort between NASA and the Lockheed Martin Corporation, undertaken with the ambitious goal of studying the Martian climate and atmosphere. The spacecraft was designed to gather valuable data and provide insights into the planet's weather patterns, atmospheric conditions, and potential for sustaining life. However, a tragic chain of events unfolded that would forever mark this mission as one of the most notorious failures in the history of space exploration. The root cause of the Mars Climate Orbiter's failure lay in a seemingly simple and yet catastrophic error, a mismatch in the units used for navigation. While the ground-based team utilized the metric system, the spacecraft's navigation software was programmed to interpret thrust data in imperial units. This discrepancy went unnoticed during the mission planning and testing phases, leading to a critical miscalculation of the orbiter's trajectory as it approached Mars. As a result of this unit conversion error, the Mars Climate Orbiter ended up entering the planet's atmosphere at a dangerously low altitude. The stresses and forces exerted on the spacecraft by the Martian atmosphere were far beyond what it was designed to withstand, ultimately causing it to disintegrate. This unfortunate incident served as a wake-up call for the scientific community and space agencies worldwide, highlighting the indispensable need for clear communication, meticulous planning, and standardized systems across all phases of a space mission. It underscored the importance of rigorous quality control, including thorough testing and verification processes to identify and rectify potential errors and discrepancies before a mission's launch. In the aftermath of the Mars Climate Orbiter failure, NASA and other space agencies implemented stringent measures to prevent such mistakes from reoccurring. These measures include enhanced communication protocols, double-checking assumptions and calculations, and implementing standardized systems and units throughout mission planning and execution. The incident also prompted a renewed focus on software development processes, emphasizing the critical role of comprehensive testing and quality assurance. The Hubble Space Telescope. The Hubble Space Telescope, undoubtedly one of the most renowned and influential astronomical observatories, suffered a catastrophic setback shortly after its launch in 1990. The images returned by the telescope were unexpectedly blurry, casting doubt on the entire project. The investigation revealed that a flaw in the primary mirror's curvature caused the optical aberration. The mirror had been manufactured with a slight but crucial error that impaired the telescope's ability to focus accurately. The Hubble Space Telescope, named after the visionary astronomer Edwin Hubble, was designed to provide unprecedented views of the cosmos and unlock the mysteries of the universe. However, the flaw in its primary mirror threatened to render the mission a failure. The news of the telescope's blurred images was a blow to the scientific community and the public alike, dampening the excitement and anticipation that had accompanied its launch. In an unprecedented move, NASA and its international partners devised a daring plan to rectify the situation. Recognizing the potential of the Hubble and the importance of its mission, they determined that a bold and risky solution was necessary. Astronauts were sent on a challenging spacewalk to install corrective optics, essentially giving the Hubble glasses to fix its eyesight. The intricate operation required precise maneuvering and delicate handling of sensitive instruments. The astronauts installed a set of corrective lenses that compensated for the mirror's flaw, enabling the telescope to produce sharp and accurate images. It was a meticulous task that demanded both technical skill and extraordinary bravery from the astronauts involved. This intricate operation was a triumph of human ingenuity and perseverance, transforming Hubble into the remarkable scientific tool we know today. With the installation of the corrective optics, the Hubble Space Telescope surpassed all expectations, capturing stunning images of distant galaxies, nebulae, and other celestial objects. Its observations have revolutionized our understanding of the cosmos, from discovering new planets to unraveling the mysteries of dark matter and dark energy. The Genesis Mission. The Genesis mission, launched in 2001, embarked on a bold quest to unravel the mysteries of our solar system by collecting solar wind particles and returning them to Earth. This ambitious endeavor held the promise of shedding light on the origin, composition, and evolution of our celestial neighborhood. However, in 2004, as the spacecraft made its triumphant return, tragedy struck, transforming the mission into a cautionary tale. Upon re-entry into Earth's atmosphere, a malfunction in the spacecraft's parachutes spelled disaster. Instead of a gentle descent, the Genesis capsule crash-landed in the rugged terrain of the Utah desert, its fragile cargo shattering upon impact. The painstakingly gathered samples, which held the key to unlocking the secrets of the solar wind, were believed to be irreparably damaged. It was a heartbreaking blow for the scientific community and the dedicated individuals who had poured their time and expertise into the mission. Nevertheless, amid the debris and despair, scientists refused to succumb to defeat. They realized that within the shattered remnants of the capsule lay fragments of the collected material. While the samples were far from intact, they still held some scientific worth. Determined to salvage what they could, scientists meticulously analyzed the damaged remnants, extracting valuable data that had withstood the catastrophic crash. Mars Polar Lander. The Mars Polar Lander mission, launched by NASA in 1992, was an ambitious endeavor to unravel the mysteries of Mars's polar ice caps. Scientists were eager to gain crucial insights into the planet's climate history and its potential implications for understanding Earth's climate system. However, tragedy struck when all communication with the lander was abruptly lost just moments before its anticipated touchdown on the Martian surface. The subsequent investigation into the failure of the Mars Polar Lander revealed that the descent engines had unexpectedly shut off, causing the spacecraft to plummet towards the surface instead of executing a controlled landing. It was determined that a likely cause of this premature engine shutdown was a software glitch that had not been detected during testing and simulations. This unfortunate incident served as a profound reminder of the vital importance of robust software testing and redundancy in critical space missions. The failure of the Mars Polar Lander underscored the need for meticulous attention to detail during the development and verification of software systems. It highlighted the necessity of extensive simulations that mimic real-world conditions to identify potential flaws or vulnerabilities. In the wake of this mission's failure, NASA and other space agencies made a renewed commitment to implementing stringent quality control measures. They recognized the imperative to thoroughly evaluate software code and conduct comprehensive testing throughout the entire development process. This involved subjecting the software to a variety of scenarios and stress tests, aiming to uncover any latent glitches or issues that could jeopardize the success of future missions. Failed space missions serve as powerful reminders of the inherent risks and challenges of venturing beyond our planet. They highlight the complexities of space exploration and the need for meticulous planning, effective communication, and constant innovation. However, these failures are not mere setbacks. They represent stepping stones on the path to progress. Each failure provides valuable lessons for scientists, engineers, and space agencies, ultimately leading to advancements in technology, processes, and safety measures. They demonstrate the indomitable human spirit, resilience, and adaptability in the face of adversity. As we continue to explore the wonders of the cosmos, failures will undoubtedly occur. Nevertheless, it is through these failures that humanity can refine its approach and strive for even greater achievements. In the pursuit of knowledge and discovery, failure is not the end but a catalyst for growth and improvement, propelling us closer to unraveling the mysteries of the universe. What do you think of these missions? Let us know in the comments section below, and make sure to like the video and subscribe to the channel.